Everyone, so this is Mansi from Java Techies, and today I'm here to explain few of the basic Kafka concepts to all of you. So we'll start with it, but first of all, what is the need of Kafka? So basically we use Kafka for asynchronous or event-based communication. Usually we use it between different microservices for asynchronous kind of communication, unlike REST, which is synchronous in nature. For example, when you hit a REST request, you get the response of that request to the client at the same time as part of that request. Otherwise, it fails with timeout exception. Suppose you have some kind of notification based system. You're sending a notification to one of the service for further processing, and you continue your work from the service A. So suppose from service A you started something and now you want to send service a notification to service B for it to do some kind of processing on something, and in the meantime service A is not going to wait for service B to respond. It will continue its execution. So this is what we call as asynchronous based communication. We can do asynchronous kind of communication with any of the messaging queue. Kafka is one of them. So we will start with it. So what is Kafka? Kafka is basically a streaming platform that is free and open source. It is introduced by Apache. Kafka is basically a distributed system, which means that you can scale up Kafka as per your need. All you have to do now is to add new Kafka nodes to the cluster, meaning to say that when required, you can scale up the instances of Kafka, and then you can distribute the load across each of the Kafka node. Apart from this, the traditional messaging queues like RabbitMQ are not the same as Kafka. RabbitMQ actually eliminates the messages immediately after the consumer confirms them, whereas Kafka keeps the messages for a default time period of 7 days after they have been received. This 7 days of time is by default, which is called retention period. You can increase it based on your own preferences, or you can even decrease it. It's as per you. It's simple configuration that you can make change, and it is used for fault tolerance storage as well, like publishing and subscribing to a stream of records. Now moving on, what are some of the features of Kafka? So Kafka is a messaging system that is built for high throughput and fault tolerance. Kafka has a built-in patriation system known as a topic. Kafka includes replication feature as well. So basically here you have leader node and certain follower nodes. So every read and write is actually performed with the leader node, and the follower nodes you have to replicate that data so that as soon as the leader goes down, any of the follower node can be elected as the leader and it will start working as leader. Kafka provides a queue that can handle large amounts of data and move messages from one sender to another. Kafka can also save messages to storage and replicate them across the cluster. For coordination and synchronization with other services, Kafka collaborates with the help of Zookeeper, and it also is very well supported with Apache Spark. Now moving on, what are the major components of Kafka? So basically the first thing is the Kafka cluster, which consists of multiple brokers. You can have n number of brokers into the Kafka cluster. Each broker will have certain topics, and each topic will have certain partitions as part of it. It can have n number of partitions. So basically what happens is there is a producer. There is a producer which can be a service that actually produces a message, or you can say pushes a message or notification to a particular Kafka topic onto the partition of that particular topic, which will be inside some Kafka broker, and your consumer will actually have a Kafka listener and will be actually reading those messages from the Kafka broker and will be processing those. So this is the basic Kafka architecture. Like producer produces a message onto a particular partition of a particular topic inside a broker, and the consumer has a listener onto that particular topic, and it reads from that topic and performs further processing of that particular message. Now moving on, so these are few definitions of the terms that we went through. So basically what is a topic? Topic is a category or feed in which records are saved and published. Topics are used to organize all Kafka records. Consumer apps read data from a topic, whereas the producer apps actually write data to a topic. So basically we read and write the data from a topic where the messages are published and from which the messages are consumed. Coming on to producer. So producer could be an application, could be anything that basically produces a message to a particular topic. So a Kafka producer is a data source for one or more Kafka topics, which he writes and publishes messages to that particular Kafka topic. Partitioning allows Kafka producers to serialize, compress, and load balance data among different kind of brokers that are present within the Kafka cluster. Now coming on to consumer. Data is basically read by consumer. So they have Kafka listeners. Consumer could be a application which has a Kafka listener inside it, and it is basically used to consume different messages from a Kafka topic to which the consumer has really subscribed. Consumers can be divided into different groups. Each consumer in a consumer group will actually be responsible for reading a subset of the partitions of each subject to which they have subscribed. Suppose you have a particular Kafka topic, that is topic A, and you have three different subscribers to that particular topic. Suppose service A, service B, service C. Now, if all these services are belonging to the same consumer group, that means if a particular message is produced into that particular Kafka topic, any one service belonging to the same consumer group has read that topic. That means Zookeeper will actually increment the offset and that message will be considered as read. So all the services belonging to the same consumer group are not going to read that message individually. It will be just one service who has consumed that message and it will be allowed to be read. A simple example of it could be there are multiple instances running of the same service which has the same consumer group, and then only one instance read that particular message. Now coming on to different consumer groups. So suppose there are three services and they have different consumer groups like consumer group A, consumer group B, consumer group C. This could be three different services which have subscribed to a particular topic. Now, as soon as a message comes into that particular topic, since the consumer groups are different, so each of the service will read that particular message and Zookeeper will only increment the offset for a particular service if it has read that particular message. So in case of same consumer group, even if one service reads it, it is considered to be read. But in case of different consumer groups, there are offsets for all the different consumers, and if one service reads it but still two are pending, so that message would be available for the rest of the two services to read. So that was the concept of consumer and consumer group. Now coming on to Kafka Broker. So Kafka Broker is basically a server that works as part of Kafka cluster. So in other words, a Kafka cluster is actually made up of number of brokers. There can be n number of brokers within a Kafka cluster, and multiple brokers are they actually work together to build a Kafka cluster which provides load balancing, reliable redundancy and failover. The cluster is managed and coordinated by brokers using Apache Zookeeper. So basically Zookeeper keeps track of all the metadata of your Kafka brokers. Without sacrificing the performance, each broker instance can handle read and write volumes of hundreds and thousands of messages per second. So basically Zookeeper is also used by Kafka brokers for leader election, in which a broker is chosen as a leader for handling all the you can say read and writes for a particular client request for certain partition of a topic. So basically connecting to a broker will bring client up to speed with the entire Kafka cluster. Now moving on to the next one. So explain the four core API architecture that Kafka uses. So basically Kafka uses first producer that produces the message. It uses consumers, it uses stream processors, and it will use connectors. So we will learn about them one by one in the coming slide. So what is Producer API? Producer API in Kafka allows our application to publish a stream of records to one or more Kafka topics. Now coming on to Stream API. So basically Kafka Stream API allows an application to use stream processing architecture in order to process the data that is present in Kafka. An application can use APIs to make input stream from one or more topics, process them, and using it basically uses the stream operations and generate the output in stream to transmit to one or more topics. So the Stream API actually allows you to convert input streams into output streams. Now coming on to the Consumer API, it's basically an application which can subscribe to one or more Kafka topics using the Kafka Consumer API. It also enables application to process stream of records generated in relation to such topics. Now coming on to Connect API, the Kafka Connector API connects Kafka topics to application. This basically opens up a possibility for constructing and managing the operations of producers, consumers, as well as establishing reusable link between these solutions. So mainly it is used as a connector. For example, it may capture all database updates to ensure that they are made available in the Kafka topic. Now moving on to the next topic, what do you mean by a partition in Kafka? As I mentioned that the Kafka broker can have different number of Kafka topics and each topic can have a n number of partitions. So now coming on to what is basically a partition in Kafka. So basically Kafka topics are separated into partitions, each of which contains a fixed order. So there can be like 0 to 2, 0 to 3, any number of partitions you can have which will be basically into a fixed order, whatever you configure. A unique offset is actually assigned and attributed to each record in a partition. Multiple partition logs can be found in a single topic. This allows several users to read from same topic at the same time, and there could be several consumers that can read from the same topic from within the particular partition. So basically topics can be parallelized via partitions which split data into a single topic amongst numerous brokers. Replication in Kafka is also done at partition level. So basically all the replication that is done from follower that is done between follower and leader is done on the basis of partitioning level that we have in Kafka. A replica is basically a redundant element of a topic partition. So each topic partition contains one or more replicas, which means that partition contain messages that are duplicated across many Kafka brokers in the cluster. Now moving on to next one, what do you mean by Zookeeper in Kafka and what are its uses? So Zookeeper is basically something that actually keeps all the metadata of the Kafka brokers and the different messages along with the partitions. So and also the offsets of the message that has been read. So basically Apache Zookeeper is a naming registry for distributed applications as well as a distributed open source configuration and synchronization service. It keeps track of all the Kafka cluster node status, whichever is up, whichever is down, as well as the Kafka topics, all the topics that are present into the Kafka broker and all the partitions. So basically it keeps all the metadata about the Kafka cluster. Zookeeper is used by Kafka brokers to maintain and coordinate the Kafka cluster. Now moving on to the next one, so you can see what is the role of Zookeeper. So as you can see, there are different points under the Zookeeper role as I explained in the previous slide. So we will move on to the next one. Can we use Kafka without Zookeeper? So earlier versions of Kafka, it was mandatory to have Zookeeper. Without that, Kafka doesn't used to work or start. But now Kafka can be used without Zookeeper after version 2.8. So basically in Kafka 2.8.0 that has been introduced in April 2021, we can actually run Kafka without Zookeeper. Now the next thing is explain the concept of leader and follower. This is quite similar to what usually is the leader follower concept. So basically in Kafka, each partition has one server that acts as a leader, and all the write of messages and read of messages are performed from the leader itself. And whereas there are different followers who are basically responsible for replicating the data from the leader, so that in case the leader goes down, any of the follower can be elected as a leader and will start working as leader. So what do you understand by a consumer group in Kafka? So I already explained this in the previous slide. So basically a consumer group is collection of consumers who work together to read the data from a particular topic, or you can say from a range of topics. The name of application is essentially represented by a consumer group. So basically it could be any string that could be consumer group. And as I already mentioned, that if there are multiple services having the same consumer group and a message is produced to which these services have subscribed, so even if one service reads that particular message, the offset will be increased, and the rest of the, suppose two more services were there, they will not be able to read that message because that is already assumed to be read by one of the consumer. Now if suppose all the three services have different consumer groups and there is a message that has been published to a topic to which these three services are actually reading the message from, in that case this message should be individually read by all the services because these services are in a different consumer group. The simple example for it could be, suppose we have one service which has three instances. So we need just one message for processing. In any of the instance can process it. So in that case, we will have the same consumer group in cases where there are three different applications, and based on the message, all these three different applications perform some kind of cleanup into their database. So in this case, we will have different consumer groups for all the three applications, because if one consumer reads that particular message, still I want the rest of the two consumers to read that message individually. So in case of different consumer groups, Zookeeper makes sure that it basically has different offsets for all the consumers. Now moving on to the next one, how do you start a Kafka server? So once your Kafka is downloaded and you have done the setup, so these are the commands to start the Kafka server. So basically first you have to start the Zookeeper using Zookeeper server start.sh file, and you provide the zookeeper.properties where all the properties of Zookeeper are mentioned into key value pairs. If you want to make certain changes into it, you can also do that. And then once the Zookeeper is up and running, you will start the Kafka broker, which is started by Kafka server start.sh file. And then this server.properties we provide, which has all the properties of the Kafka broker. And basically it is also there into key value pairs. If you need to make some changes, add some new properties, then you can do that. So this was for, I think, Linux system. You will get BAT files as part of Windows. If you want to run Kafka on Windows, so there will be a separate folder for Windows into which all the BAT files will be there. Similar BAT files will be there, and you can run them in the similar manner in order to start your Kafka broker on the Windows machine. Now the next thing is describe partitioning key in Kafka. So basically in Kafka, messages are referred to as records. Each record has a key and value. So every message has a particular key and the value. For record partitioning, record key is used. So basically we partition the record on basis of key. So there will be one or more partitions for each topic. Partitioning is basically a straightforward data structure. It's the append only sequence of records which are arranged chronologically by the time they were attached. Once a record is written to a partition, it is given an offset, a sequential ID that reflects the record's position in the partition and uniquely identifies it inside it. So as I mentioned, that partitioning is done based on key, and all the data in Kafka is basically part of records. We call it as records, and each record has a key and value. And partitioning in Kafka is done on the basis of key. So basically, by default, Kafka producer uses the record key to determine which particular partition of the record should be written to. And the producer will always choose the same partition for the two records with the same key. So that's it from my side. Thank you so much. Thanks for watching. Do like, share, subscribe and comment on our video. Thank you. Have a good day.